Right, thanks for the introduction. I'm Adalberto Simeone from the KU Leuven in Belgium, and this work was done in collaboration with our co-authors Marco Speicher, Andreea Molnar, Adriana, Wilde, and Florian Daiber. So what we do? We explored this concept of contact teaching in virtual reality, but why doing it in VR of all places? Well, I think VR provides us with some compelling advantages to use it as a platform for learning. Now, we can do in VR things that are not possible in reality, like go back in time and display reenactments of historical events. We can be inside the human body to learn about anatomy, or we can be on another planet and see what it will be like to be there. We could be inside an engine to see how it's made up. But for a long time, this concept of using VR to support learning has been a bit confused depending on the community of academics that you refer to. So for a while, educational virtual environments refer to things like Second Life, where they used virtual environments that were not immersive to provide a way to support learning. And even when they were immersive, they still, for a long time, they have been focused on the concept of reenacting a virtual classroom in a 3D immersive space, such as these works that I'm showing you. And then more recently, we have seen some immersive VR works on educational virtual environments in which they used a game-like concept to support, for example, learning another language. And also more recently, we have seen at VR this concept of using pre-recorded video material to support learning. We've done something a little bit different. But also in terms of commercial learning platform, there's also a lot of interest. As I've shown you, this is the Body VR, which uses a virtual tour inside a human body to present some of these concepts. Other platforms that are available on Steam VR that you can try for free include the Immersive, which uses virtual interactive prompts to learn about different tasks, or also using VR to support 3D version of a lecture into a classroom. And other platforms such as Class VR use 360-degree videos to support learning. But we saw that there were no examples of contact teaching. So what we had in mind was to use VR as a platform to deliver lectures and lessons, but where the instructor will give something akin to a live performance in virtual reality, so that it didn't rely on a fixed and scripted tour of a virtual environment to provide the learning material. So the actual explanation of the material would happen in VR by explaining the concept. So what did we do? We designed a VR lesson which is based on the 4 fundamental tasks of 3D interaction, so about learning about 3D interaction itself. And it was evaluated in a between groups study. And so we designed 2 versions of this VR lesson, so based on the same material. The first one was based on a single user version, which followed a script, so to say, in which there was only the student user immersed in VR. And then a second version, which had 2 users, so the student and the instructor. So the single user VR version used pre-recorded animations to demonstrate concepts. So, for example, just to illustrate manipulation. So we recorded the action that an instructor, if they were there, will take. Whereas in the 2 user VR version, we had another person playing the role of the instructor, together with a student user, and they would perform similar action in real time. So there was a script, and the instructor tried to follow it as best as they could. The blue orb represents the headset. So the system we have built is available on GitHub. We are currently in the process of updating it to the last version of Unreal. And it is heavily blueprint-based, so if you don't know what blueprints are, a way for the Unreal Engine to provide visual programming. And the system itself is based on 4 components, or 4 blueprints. And so the first one defines the data that is displayed in the non-dominant interface, which is text, vertical display, pictures, video, and there were audio voiceovers to the material. Then the second blueprint defines the changes that happens to the user, such as, for example, changing the way their interface looks like. For example, as you've noticed, they had a regular controller for the right hand, but then at some point, they switched to a hand controller. The third blueprint defines changes that happen to the virtual environment while the lesson is going on, such as changes to the environment, such as modifying the layout of the environment in which the two users are immersed. And then the fourth blueprint defines the changes defines the rules for the progression of the lesson. This is particularly relevant for the single user version. So what do they have to do in order to progress to the next stage, such as, for example, throwing the ball on the cubes, and that displays the next button, which allows the user to progress. Whereas in the second version, it was the responsibility of the instructor to go through after the student communicated their will to do so. So in terms of the design of the VR lessons, we note that there isn't yet a pedagogy of VR. In fact, there is this paper by Fowler, which was published in 2015, which describes some 3 learning stages of a proposed pedagogy model for VR, which are conceptualization, which is the description of what's going on of the materials of the lesson, and then a construction phase in which the student can experiment, and then finally a dialogue stage, but in which we didn't address so much in this experiment because we wanted to keep things consistent. And we do know that if the student were able to talk with the instructor, that will bias it for the two-user version. So we try to keep conversation between the student and the instructor as short as possible and as not biased as possible. The structure of the lesson then follows the following. So there were 4 scenarios, one for each of the interaction tasks. And at first, the instructor or the animation presented the algorithmic underpinning of several interaction techniques. And then the student can experiment with some interaction prompts, so they can try to experiment with what they have just been presented with. So to show you a little bit of how the lesson looked like, so this was for the selection task. So the instructor was talking about how the ray casting algorithm works and what happens, for example, if the ray doesn't collide perfectly with the 3D object due to bounding boxes and so on. Then in the manipulation task, we had the instructor present the difference between natural and supernatural manipulation techniques. So, for example, as you have seen in the video before, the natural interaction technique would be the hand metaphor, able to reach objects at arm's reach. Whereas for the supernatural, we use the famous go-go technique, which is a linear mapping between the user's body and the distance at which the arm is extended to allow to reach objects that are farther away. And then in the third scenario, we showed different navigation techniques. One that was based on an on-rail navigation, as you can see in the video. And the second explained how the teleportation algorithm works as it is implemented in the stock Unreal Engine version of it. And then finally, a representation of the world in miniature technique in which the user or controller was replaced by this version of the environment, and they could use the trackpad to select a teleportation location. And then finally, the system control scenario showed the difference between different types of menus, such as a device-based menu, which allowed the user to select the appearance of the shape in front of them, and these objects were shown around the device. Then the second type will be the object-based menu, in which the possible choices are displayed around the object, and the user can use the pointer from the controller device to select different appearances of the object. And then finally the last type, which is a word-based menu, a menu that exists in 3D space, in this case as a flat polygon with some traditional widget-like components such as buttons and checkbox and so on, and the user can point at these buttons to select what is displayed. In terms of evaluation, we had two main goals. So first, to study the differences in engagement between the two versions of the lessons, and then elicit feedback on the three-dimensional user interface. We had 36 participants, of which 14 females, and they were aged between 19 years old and 51, and they were divided in two groups of 18 participants each, so 18 for the single user version and then 18 for the two user version. In terms of procedure, student users went through each of the four scenarios, and which, as I explained, there was a first explanation of the material, and then they were allowed to experiment with each of the techniques presented in the scenario. And after going through each scenario, they took a break in which they filled some questionnaire on how clear the explanations were, how useful the demonstrations were, and other such like components, such as evaluation of their own performance in the scenario. And then at the end, we had a final exit interview in which we also asked some questions about what they thought about the lessons, their role in the lesson, and their overall suggestions for improvements. In terms of quantitative feedback, we measured the time in which users were interacting with the interaction prompts and the time in which they were looking directly at the information window. But we do know that time alone cannot be an indication of how interesting or how engaging the lesson was going to be. So we also measured other information, such as the progress. Indeed, some of the scenarios that I've presented offer the user to progress farther into their completion. Some of them were just something that they were to do once, like, for example, selecting one of the 3D objects, but the other could be completed, such as reaching the exit of the labyrinth maze in the navigation, and sorting the bricks from the plates into in the manipulation scenario. And so we used that as an indication of whether the user was engaged in the lesson or not. In terms of results, I'll first talk about the time collected about in which the user were looking at information window. And so we can see a significant difference in terms of the amount of time. This was measured by coding each video, and so only the time in which the window was in the foreground was measured. If they were doing something else while the information window was in the foreground, then we didn't take that as an indication of the user that I was looking at the window. Indeed, what happened in this case is that in the two-user version, students were looking at the instructor mostly, and so they didn't look at the information window. Then, in terms of the interaction time, here too we can see a significant difference, and the students were spent more time in using the interaction prompt when they were together with the prompt. Then, about the progress that we did, we saw that the student users, they went farther into the completion when they were together with an instructor. For example, in this case, they had to sort the bricks from the plates, and many users in the two-user version completed this task. Whereas in the other version, the single-user version, the student user did it mostly just once, and then as soon as they could, they progressed to the next phase. In terms of the results from the questionnaire, we saw that in general the explanations were considered to be clearer, significantly clearer, and more helpful in the two-user version as opposed to the single-user version. Also, users had a subjective recollection that they had performed better in the two-user version. And also a significant preference in terms of overall preference to the approach as expressed by users in the two-user version as opposed to the single-user version. So what did we learn from this experience? So in general, we could say that there's a positive impact of having an instructor present together with the student. This led to some higher results, both qualitative and quantitative, for the two-user version. Some of our participants said that having an instructor reinforces the fact that they feel they are being guided or advised by a real person, and that it was something that they appreciated. And also something relevant to point out was that the VR interface or the VR environment, it was a bit difficult for our student users to distinguish between objects that were interactive and objects that were not interactive due to the design of perhaps of the object also looking alike, which is a common problem because there are probably less accepted conventions in VR than in desktop interaction. Also, another problem that we found was the spatial awareness. So the experiment happened while the two users were in the same space. So at the beginning, they were facing each other, and they maintained the same spatial relationship in the physical space as in the VR space. But especially in the navigation scenario, as soon as they teleported, then this spatial relationship was lost. And this created some confusion. And also, we noticed that it's a bit problematic to maintain awareness of what the other person was doing, especially in some of the interaction techniques. Unless this is built into the environment, into the interface, it's difficult to know what the other user is going on if they are not in direct view. And this could be interesting, especially for scenarios in which the instructor is lecturing to a large audience and there's movement involved, and we want to know what's happening where. The information windows, as noticed, was also not looked at in the two-user version, and so perhaps this indicates that if there is an instructor present, then we have to look at different ways in which to present this information, such as instead of locating it to a controller device, perhaps placing it somewhere where it can be more easily viewed by the user if relevant. So, in general, this was a very interesting experience because we wanted to focus on this aspect of doing contact teaching in VR. But this provides us with various limitations, the first of which is the time it takes to create the materials. There is no this PowerPoint of VR that is available. No? And so everything had to be implemented in a process similar to what developing a game looks like. And so because we have to look at all the possible events that can happen, all the ways in which a student can use the materials that you have maybe not looked at. And also, we also recognize that this is just a single focused investigation in what is probably a much larger space, and so we are confident that this warrants further investigation, especially on the long-term issues and challenges of doing a VR course. In fact, one of our desires will be to actually design a year-long course that will be only delivered in virtual reality. Right, yes, so this was our work on learning in virtual reality, and this concludes my talk, so if you have any questions, I'll be happy to take them. Thank you.
Questions, but I thought this is your time, so I want to ask you, is there anything else anecdotal or anything else you'd like to share? This is your time. So if there's anything else you'd like to tell us?
Yeah, we collected several feedback on the participants. So there were some who commented that perhaps having the instructor present with the user provides some sense of authority in the experience. So that's why it's necessary to continue working on this to ascertain whether students felt like obliged to go on, or if this was truly the effect of having another instructor present in the experience. But as we said, as I said in the beginning, the instructor was not really talking with the student user, because I think that would be unfair to the single user version. So they were only responding to clarification, but didn't offer additional information to what was available also in the other scenario. So if that were allowed, so to speak, then that would provide further incentives to have this kind of a system.
Number of user study, right? We have to narrow things down so that they can be compared. You can say it's unfair, but on the other hand, that's really part of the user's advantage of that.
Yeah, exactly. No? Mm-hmm.
I have a question. Have you considered using the Wizard of Oz where the participants think that it's the machine instead of an instructor?
Yeah, how did you learn about my next project? Yeah, yeah, we wanted to test that in VR. We wanted to focus on doing this kind of studies in virtual reality. So perhaps that's something we are going to look at next. Yeah.
Our next speaker?
Yeah, it's still me. I'll be here all day.
Right, so this one is just the first one. It listed as a printed program, first of the session. Looking at the effects of distractor interactivity, redirected walking, virtual reality. So I had a bunch of people in the room here, there's people in that area. I found this interesting. I think you guys might also find it interesting.
Yeah, as you notice in the